So, you've just installed your new OpenHaldex-C6, and what you would like is you'd like to understand all of the settings that are available to you. So, in this video demonstration, I'm going to connect as if I was a brand new user. So, I'm using my phone, it's a Samsung phone, and if I open Wi-Fi networks, I can connect to OpenHaldex-C6. And once I've done that, I can then go into a browser. Now, I was previously looking to be able to control my steering wheel, but go into a browser and you can type in openhaldex.local. And when you go to this website, this will bring up the user interface that allows you to control all of your OpenHaldex settings. Now, all of these settings are remembered when you turn the unit off. If you were to remove the unit from the car, they're all persisted in what's called an EPROM. So you don't need to use your phone all the time. You just need to be able to use it to be able to set it up. Now, what you can see at the top is there's two ticks. So the chassis can is healthy and the Haldex can is healthy, and we're currently in the front wheel drive mode. From here, the first thing you want to do before you do anything at all is you want to go to the settings button. And here you'll be able to choose the Haldex generation that you're running. So this is just a drop down. You will go in and you'll choose, depending on what you're using, generation 1, 2, 4, or OCQ or OAY. Also the SAB stuff's in here as well, but just now, just for a demonstration, I'm using OCQ. So I will select that. And the next thing you want to do is you want to learn the Haldex. Now, originally when this project started, we were using a formula in order to calculate what the lock percentage would be. But that's quite old school, and in the mid-range, it wasn't quite as accurate. So I've added in a learn Haldex, and what it will do is it will plot each theoretical lock against what is actually returned by the differential. Now, not all OCQs, if you're using the Gen 5, are created equally. Some of them use different can frames, some of them have different torque ceilings. And I've learned this through trial and error, but what you might find is when you press the Learn Haldex button, what you want to see is a constantly changing return value. So you can see that gradually increasing as time goes on. Now, I'm doing this real time as we speak. But on some of the variants, what you'll find is the return value will jump around. So it might be 40 and then the next second it's 70 and then it's back at 30. And if that's the case, what you want to use is use the fixed hunting option, and that will change how the CAN data is sent across. But you can see this one learned really, really nicely. We can continue to scroll down. So what you can then do is you can use specific buttons in the car to force a mode. And I've tried to keep this simple because ultimately people are either going to use the hazards or they're going to use the traction control, because they're really easy to get to. You don't have to navigate through loads of menus. You could use it, you could set it up to be anything you wanted, but it becomes really cumbersome. So we're going to use the traction control to force a mode. You don't need to use this, you would just turn it off. That's the setting off, and this is the setting on. And if you decide you want to force a particular mode, you can go in here. So you don't need to have it fully locked. You can make it front wheel drive if you wanted. I like it fully locked. You can then use the hazards to force a mode, or you can choose not to. Those options are also there. And that allows you to then select a mode in there. There is external control buttons on this as well. So on the module itself, there is a pull low signal. So if you were to link that to a physical, you installed a new button on your dashboard, you can decide what that button does. Now, some people might want to, when you press it, you'll advance to the next mode. So it will sequentially go through stock, then front wheel drive, then 50-50 every time you press that button. But that might not be what you want. So you can also choose here if you want it to advance to the next mode, or if when you hold the button down, you can force a mode. Next up, you can then choose a priority. So what I typically do is, in a drag racing event where you'll have the hazards on because you want to do a burnout, you also want the traction control off because you don't want any throttle cut. And when you're preparing to do a drag launch, what you don't want to do is have to think too much. You're already trying to focus on doing the actual launch itself. So the priority means that you can turn the traction control off and it will go fully locked. But then when you turn on the hazards, that will override. So you can see here that hazards is first. So hazards will override the traction control, and that will override the external interface. And if you drop that down, you can choose whatever priority you'd like. But typically, that is the go-to setting. Now, on Gen 1, the brake and handbrake inputs are physical wires. So they can also come into the module and they can be passed back out of the module. It's not usually wired into the harnesses because really that's for an extreme user. That is for edge cases where you want to get every single ounce of everything out of it. Once you went into Gen 2, it was just the brake that got a physical wire, and then once you get into Gen 4, all of that was passed through CAN. Now, you can decide when you come off the brake, do you want it to, disengage, or do you want it to stay locked? And this will change the balance in the car, those kind of things. So these options are here. You can have it follow the brake. If it's the wrong way round, then the software thinks you can get it to invert it. Similarly, you can follow the handbrake and you can invert the handbrake as well. If you don't want the controller to do anything at all, if you just want it to pass through, so any message, any CAN message that it receives, it will then just forward onto the Haldex, and likewise from the Haldex back. So you can disable the controller. Now this would only be if it's going in for servicing, if it's going in for anything like that, but there is generally no requirement to use that setting. Now, because I'm demonstrating this on the bench just now, I'm running it in standalone mode. You would typically have that setting off because you would usually have it in a normal stock car, stock-ish car. There will be instances where people have fitted these differentials into all sorts of stuff. So I've left that standalone feature in there just so that if you do need that control and you don't have all of the OEM ECUs, that is an option there. Now, the use CAN if available is quite a good setting, because in the instances where the standalone mode is enabled, you might still have speed available over CAN. Now, what I'm typically thinking of is a 1.8T in a Mark II, somebody's four-wheel drive swapped it, or they've stuck an R32 in it. And in these instances, you can add the hall sensor that would be your speed signal, and that can go into the ECU. Now that means that if you were to attach the CAN lines from the ECU up to the Haldex controller, you can then read speed and throttle. So if you were to use CAN if available, that will give you all of the available CAN signals to be able to be used. It's a good feature to have. The broadcast over CAN is really just a feature ultimately for people with aftermarket displays or aftermarket ECUs that want to do a bit of logging. It's more of an advanced feature. And what it will do is it will broadcast the current lock status, the current mode, all of the things that the controller doesn't need to see, but I like to be able to have displayed on my own dash. So that's why I've added that feature in. However, this occupies an extra CAN address. So you might find that if you get a sporadic warning light, it's probably because this setting is going to be enabled. It doesn't always need to be enabled. It should only be enabled if you actually do know what you're doing. Now, for me to get this set up to work, in order for me to do any logging, anything like that, we added SavvyCAN in, and it was actually Chris, one of the contributors on the GitHub, that had done this, and I really do thank him for this. It's been a great addition to it because it allows me to go out in a normal running car and I can log the data so that I can then look at it in the future. And there's two options for this. You can either do it over Wi-Fi or you can do it over serial. Typically, if you're going to be logging, you're going to have your laptop with you anyway, so you will always do it over serial. It gives you faster baud rates. You will get all of the CAN traffic. If you use the Wi-Fi, yes, it will work, but you will miss some frames. So if you're a real advanced debugger and you need that functionality, use the serial option. Enable live diagnostics. So the way the current Gen 5 and Gen 2 and 4 work, Gen 2 and 4 use what's called a TP interface, KWP. It's an old-fashioned diagnostic interface. And Gen 5 then uses UDS. So if you'd like to use UDS, enabling this feature will then basically it turns it into VCDS. So it will start a communication link with the Haldex diff as if it was VCDS, and it will display voltages, current PWM signals, all of that good stuff. Now what I did add in here is if you then try and connect with VCDS, it will notice the incoming frames as if VCDS was there, and it will then turn off live diagnostics. So you don't need to turn this off if you're going to then use VCDS to establish a connection. It might interfere though. So it's worth remembering, if you can't communicate with VCDS, double check that this is either enabled or be conscious that you might need to disable it. There is an onboard button. Depending on where you've mounted it, it might be susceptible to getting bashed, and if it was to get bashed, that will then change the mode. So if you find that happens, you can then disable the onboard button. Likewise, there's an external button. You can also disable it as well. If you've wired it in and you've decided you no longer want to use it, you can then turn it off with this. On Gen 1s, it doesn't matter, and doesn't actually matter on Gen 2 either, because the ignition live is what powers the Haldex unit. But once you get up to Gen 5, the Haldex has two means of power. It's got a permanent power supply and it's got an ignition power supply. Now, the reason that all the harnesses and all the wiring diagrams that I've done are made the way they are is because my worry is when the car's asleep, it will every so often pull that Haldex ECU just to double check it's still there, almost just like a handshake. Hello, are you still there? And my worry is if I was to power it off of ignition live, yes, the controller would be off, but my worry is it then can't see the Haldex ECU, and my worry then was that you got errors on the dash. So if you enable the can sleep, and what I typically then do is I'll enable the aggressive function. And what the aggressive function does is once the chassis frames per second reduce to a certain value, it will then go to sleep. So you can see just now the chassis count frame is between 2 and 6. So what I'll then do is I'll set this slider to just be above 2. So just now the car is sleeping. So when it's running, when it's a normal running car, this will always be around 1,000. So you don't need to be exact. But ultimately, you want the slider to just be slightly above the sleeping count frames per second. Now, this will vary chassis to chassis, depending on what you've got installed, depending on what came from the factory, all of that good stuff. So this is a variable. There's probably other ways I could have done it, but this made the most sense to me. And then you've got LED brightness down the bottom. Again, depending on where you've mounted it, you might find that onboard LED too bright. You might like to turn it off. That option is there. If you go into Diagnostics, this is just a kind of light page on the current statuses of everything. So you can see that the chassis can and the Haldex can are both healthy, and you can see that at the top as well, but it's just in there for information. This is current information from CAN bus, so you can see throttle percentage, and you can see the current speed, and you can see the traction control and the ASR status and the hazard status as well. And this is good for debugging, because if you find that you're pressing a button and something isn't happening, so if you turn the traction control off and this doesn't change to off, that means that we're looking at the wrong bit. And that's not the end of the world. We can go in and we can do a little bit of logging. We can log when you press these buttons, and we can then figure out what it actually needs to look like. But just now, on all the cars that I've tested, this all functions. The brake and handbrake signals, so currently the physical inputs and outputs, it shows you the status here. So if you were to wire these in, you'll see the current brake coming in and you'll see the status of the brake coming out. So that advanced feature that we spoke about, where it could invert the signal, it could follow, that will give you an idea of what the actual output is. It's a good debug. And then brake over can and handbrake over can. Now, the frame editing, this is for really advanced people. So all of these frames are what is required in order to get no fault codes on the differential. Now, this is in standalone mode just now, so if you weren't in standalone, some of these will be turned off. Now, if you try and learn the Haldex and the learn procedure isn't as clean as it could be, what you can do is you can go in to here and you can enable some of these. And what you might find then is that the learn procedure is better. Now, if that is the case, let me know, because that means I've missed a frame and I'd quite like to add it in so that it works normally. Down at the bottom, you can go into Wi-Fi name. That's self-explanatory. You can make this whatever you want. You can make it my Haldex, my Golf R, my burnout machine, whatever you fancy. and there was a lot of requests for people can then go in and they can edit and they can change to whatever they want. You know, they can change my settings at the drag strip. So I've added a password in here. It's a minimum of 8 characters, and it's a password for the Wi-Fi. Just a note that I've left the button, so if you were to long press the mode button, it will reset the password back to empty if you were to forget. And then some information down here, your current firmware, how the CPU is coping with all the data that's coming in. So that's Diagnostic. There's a good bit of information in there, but for most users, all you're really interested in is setting your generation. You're going to learn it. You'll get to pick modes with whatever interfaces or whatever buttons you'd like, and then you would choose some final settings down here for CAN. In the expert mode, this is typically what I use. I won't usually use a fixed mode, because I know that in the expert mode I can decide what lock percentages I'd like at any given time. So you can see my table here. I'll leave it up so that you can screenshot it, you can put in your numbers, you can make suggestions about how yours is better than mine. And it probably is. What you'll find here is, as you press the throttle, the column on the left will start to trace down, and as you start to increase the speed on the right will start to increase. And as you drive around, that will draw circles, and it will go up and it will go down, and you can then decide what lock percentage you'd like at any given time. Once you've picked the numbers you'd like, just hit Save Tune. If you make a mess of it, just hit Restore Defaults. Take a screenshot, start again, whatever you think you need to do. So just now I'll actually show UDS as well. So just now I'm actually connected to VCDS, just to give you an idea. Because this isn't in a car, I've obviously now disconnected from VCDS, so that's why there's now a cross at the top. But what that does mean is I can go down to Enable Live Diagnostics. And you can see here that I've queried the current state of the Haldex, so you can see the module temperature. It's reasonably warm in Glasgow today, believe it or not. Current voltage temp is 14.3. It's a really healthy bench supply. And the current blockage, so if I was to change that to a mode, you see that goes up to 100%. And we come down here and you can see the current getting drawn, and you can see the PWM signal. I do need to look at fin temp because that is 100% wrong. That scaling is incorrect, but I need to look at it. Now, you can see here that UDS data is live. If I was to reconnect with VCDS, I'm going to show this will then go to 0, and it's paused because I've tried to connect with VCDS, and there we go. I've now connected with VCDS. So that's great. I'll then close the controller, and then this will re-enable. There we go. Okay. So that's an overview of just what all of the settings that you could. There's basic settings in here. You know, if you want to disable it under a certain speed, above a speed, things like that. But these are just really basic settings. Typically, I'll use the expert mode because it gives me the most control over all of the settings. So that's all there really is to it. If you've got any questions, join the Discord. Let me know in the comments.